The objective of this work is to study if the Morrison equation is applicable to calculate the wave load on this structure or not. Then I will compare between the semi-submersible wind turbine response on two locations, North Sea, which represent an open water location, and the Aguasadura area, which represent a coastal side by using long-term analysis. The content of this work, I will start by a brief background, then move to the floating support structure geometry, and then how to calculate the environmental load, then the long-term analysis result, and finally conclusion. The background. The offshore wind turbines are gaining attention for their ability to capture the wind resource available over coastal water. And till now, the most satisfactory design approach is based on the long-term, and a full version analysis is required in the design process. A methodology was proposed by Getschwarz in 1993 for the long-term formulation. Finally, Chakravarti and Nijad have described three different approaches to estimate characteristic long-term extreme values. The float support structure, as we can see, it consists of 3 side columns and then one main column in the middle, and they are connected to each other by a bracings. To calculate the wave load, we will use the Morrison equations, which is composed of 2 parts, drag part and then inertia part. The CD is the drag coefficient and CM is the inertia coefficient. And the U are the water kinematic, U and A are water kinematics, velocity and acceleration. If the diameter of the member is less than 20% of the wavelength, Morrison equation is applied. But if it is not, diffraction force must be taken into account. To calculate the water kinematics, we have used the linear wave theory as it is the simplest and most applicable approach for deep and transitional water waves. And those are the formulation for the horizontal water particle velocity and the horizontal water particle acceleration. About the sea state description, those are the sea state of the North Sea and the Aguasadura area. The North Sea represents the open water location, and the data is collected on 29 years from 74 to 2002, and the significant wave height range is from 0.25 to 12.75. The peak period is from half to 29.5. About the Aguasadura area, it is a coastal area. The data is collected on 7 years from 2005 to 2012. The significance from 0.2 to 7, and the peak period from 3 seconds to 17 seconds. To represent this sea state, we have used the Jones-Webb spectrum, as we can see, to estimate the sea state. And this is the equation applied. The WP is the peak period, and this one is the shape factor. About the long-term analysis. The long-term analysis calculation procedure is described like it is dependent on the short-term calculation. Sorry. This is the short-term, depend on the Raed distribution, and the R is the variance of the response spectrum. To calculate the response spectrum, we must calculate first the Jones-Webb spectrum, or the wave spectrum, and then multiply it by the transfer function, which will be calculated. And this is the variance, the area under the response spectrum. Then we can integrate and obtain the long-term distribution. About the result and discussion, first of all, the dimension of the structure, as we can see, this is a side view of the structure, and this is a plan view. The dimension, the freeboard is 10 meters, and the structure is composed of, as I said, 3 vertical columns. Each column of those has 2 different diameters, as we can see in the plan view. The offset column and the bottom column. The offset column has a diameter of 12 meters, and the bottom column has a diameter of 24. The main column, which is in the middle of the structure, has a diameter of 6 meters. Each braces that connect the columns with each other has a diameter of 1.6 meters. Now we have studied if the Morrison equation is applicable or not. I have assumed a water depth of 200 meters and a wave height of 20 meters. And then the wave period is 10 seconds, which means a wavelength of 156. And the other case is 8 seconds, which make the wavelength 489. Then, as we can see, I have experimented the applicability of Morrison equation for 3 diameters. The large diameter, which is the diameter of the bottom column, which is equal to 24 meters, and the diameter of the offset column, which is 12 meters, and the diameter of braces, which is equal to 1.6 meters. Then I have calculated both ratio and going to this chart, and then see what is the range of applicability, if I can use Morrison equation or it is not applicable. We have seen that most of the ranges is under the Morrison equation, except in this case, there is a critical area between the diffraction region and the large inertia region. So we have decided to use the Morrison equation in the estimation of the wave load. To estimate the wave load on the semi-submersible, I have assumed that the wave crest of the wave is at the center line of column 1, as we can see. The resultant force that are calculated is given by this equation. We have calculated in the 3 directions, x, y, and z, and calculating the resultant force. The coefficient used in the Morrison equation is here. We have varied the drag coefficient and make the inertia coefficient constant. Those values are taken from Robertson wall on the OC4. This figure shows the wave force along each column on the OC4. This is for column 1, this is for column 2, and this is for the main column. As we can see, the straight line represents the difference between the offset column and the bottom column, as the force is different. Then we have calculated the pitch moment. After calculating the force, we have calculating the pitch moment around the point at the mean water level, which represents 0, 0, 0. And we have calculated the force center and make calculation of the pitch moment. This is a transfer function of the wave force and the pitch moment. This work has done for 86 frequencies from 0 to 6.5. And then finally we have obtained the long-term assessment between the North Sea and the Aguasadura area. As we can see, there is a deviation between the long-term calculated in North Sea and the Aguasadura area. But for the wave force, the maximum deviation is around 47%, but in the pitch moment is around 51%. Finally, for the conclusions, the wave position play an important role in the determination of the resultant wave force. By increasing the wave period around 45%, the effect on column 1 is to decrease the resultant force by 69%, and decrease the force on the main column by 66%, and increase the force on column 2 by 90%. Inertia force are the predominant for the largest diameters taken into account. The diffraction effect should be carefully taken into account in the large diameters. The long-term analysis showed that the maximum deviation of about 47% in a wave load and 51% in the pitch moment for Aguasadura. Thank you very much.
Very interesting presentation. So we are going to questions. So I don't know what to say, but what is the difference between the force on the structure between the two seas. I see that the inner Visagora is smoother.
Of course, because it is a coastal area and the North Sea is an open water area. But
yeah. So the machines installed in Visagora can be less damaged than in the other sea.
of course,
So
yes.
it's a good place to put machines.
Yes, but it depends on the energy because Acosador is a coastal area, so I think the wind speed is much less than North Sea. So there is an advantages and disadvantages. This is the problem. But here I have related the difference between the sea states to be represented by long term. Because my sea state is different, but how it will affect on the long term analysis, I was asking why or how much will it be affected. So that is why I have studied this point and see that wave force will be affected 47%. So it is a large amount.
You talked about the diameter of the columns.
Yes.
So maybe the design of the columns might change, not only to talk about the circular shape, but
Yes.
the other different shapes could maybe be tested in
Yes,
order to
it
face
could.
the waves.
Yes, it could.
You talk about the diameter, but it's just only for the shape. This is the best shape, the
Yes.
circular one.
Yes. This is OC4 design with the same diameters. I didn't change the shape, but it can be done. It can be done and test how it will affect the force.
Okay. Thanks.
Thank you
I
very
like
much.
the presentation.
Thank you.